Great Search, brought to you by DigiKey and Adafruit. Every single week, Lady Ada is a part of engineering, help you guys find these things on digikey.com. Lady Ada, what is the Great Search of the week?
Okay, so this week, I'm actually going to be breaking the law a little bit. So this is an RP2350 design. And in the data sheet, they're like, look, there is this, it's marked 1.2 volts, but it's really 1.1. So pretend when you see 1.2 volts here, it's 1.1 volts. The core of the RP2350 runs at 1.1 volts. It's then the IOs are level shifted to 3.3 volts, or they're even 5 volts safe. But the core itself runs at 1.1. And instead of providing it with an external, instead of having an LDO inside, they put in a DCDC converter, which we've seen in a couple other chips, like the NRF52840 has, I think, a DC. It's optional, but you can use it. And if you want to have ultra low power usage or like more efficient usage, you have this inductor, and then you have like the components in that area, which will let you have a buck converter that converts from the 3.3 volt power supply, which is what that you provide the chip, and it will buck it down to 1.1. So if you look at the data sheet, they say it's like about 70% efficient, which isn't too bad because it's built into this chip. And the inductor has to be able to handle up to 200 milliamps. So they're basically saying, the 1.1 volt regulator should be able to handle, the DC converter is going to need to supply up to 200 milliamps. That seems a little bit high, like a core of a dual, M33 microcontroller running at 150 megahertz. But maybe if you're overclocking and you're doing a lot of stuff and you're using all the peripherals, there could be some reason that you could get to 200 milliamps. While I have, my layout has the 1.1 volt regulator and the inductor, and I'm using their inductor as required, there are some situations where I might end up not using the DCDC. One is it takes up a little bit of space, and I might actually need that space, and I don't need the low power efficiency of the DCDC. Like there could be some situations where the current draw of a peripheral or some other accessory on the board is so much higher that I don't care that I'm losing 10 milliamps or something of current to a low dropout regulator. And we saw this actually on like the Bus Pirate. When the 2350 came out, the Bus Pirate 6 design was published. The author said, hey, actually I didn't want to use the DC converter because there was some issues. It was a little noisy. I wanted to reduce EMI, or it was not always coming up. Whatever, I just replaced it with a low dropout regulator external. And you can do that. And there's nothing wrong with it. There's, I think in the HUD, they tell you how to do it, but basically you don't connect LX. I don't think you need to, I think you connect FB to the 1.2 volts. And then you just, I think instead of VReg in, you just give it 1.1 volts and you have the regulator instead of the inductor. So you just, it's some of the, you have to noodle around a little bit, but basically you can do it. I'm not 100% sure I'm going to go with this, but I do want to have the option, if I don't want that DC-DC converter, to go with the LDO. And so I thought I would go to DigiKey and find a really tiny 1.1 volt linear regulator that can take 3 volts in, has 200 milliamps capability out, is really tiny, so not a SOT23 or like, a SOT223 or whatever, like something extremely small. And if there's something with low quiescent, great, but that's not important. The most important thing is 1.1 volt out fixed, because I don't want to have the extra components to set adjustable. 200 milliamps out, 3.3 volts in. So let's go to LDOs. And there's like 70,000 LDOs. So as usual, we're always going to go for active. I want only one regulator. And I'm going to say normally stocking, and I'm going to just for now exclude marketplace products, just so I'm only looking at basically like, these are live, these are things I can buy. So I'm going to ignore this. And I'm actually, because it's a little confusing, it's like, do I want adjustable fixed, programmable fixed? I actually just want to look at the output because I know I want a 1.1 volt regulator. And you know, you can also look at 105 or 115, but when I click 1.1, it says that there's 139 options, which is pretty promising. So I'm going to select that. And then now I will set fixed input. And then the input max, because I'm going to be feeding it from my 3.3 volt regulator, I'm going to select all but the 2 and the 3 volt because those are not high enough. And then I'm going to apply. All right, so that gets me, you know, 130 results. Oh, and then the current output, right? That's another important thing. So I need to at least 250. I'll just select 200 and up. Sorry, 200, not 250. And then we'll see. So there are a lot of SOT23s. This doesn't look too bad. This 6W SON. I don't know how big this is. It's 2x2 or 3x3. So the 2x2 is actually pretty nice. I don't want this one. I don't want that one. Maybe I can filter out. It's really hard to filter out packages, but maybe I'll try. So package case, I'm going to remove the LCSPs, the BGAs. Yeah, just remove the BGAs, because I don't like those. They're hard to work with. Definitely not SOT89, definitely not TO220. And then I think even the SC70s are going to be too big. I think this is a good set. Okay, let's see what comes up. So what is this package called? What do they call it? SC74. Okay, it's a smaller version of the SOT23. But the one that I actually really thought was really promising, and also that lots in stock and is a low price, is this 4xDFN TLV74311. So this chip, it's 1.1 volt output. It's only 1 millimeters, but I like the little corner pads. So let me look at the data sheet. Let me just check what the pinout is. It's available in SOT23 and X2 SON. I guess that's what it's called. And let's look at the X2 SON layout. Okay, so if it's the X2 SON, there is in, out, ground, enable. They don't have like that non-connected pin. And what's nice is that middle pin is thermal, so you can just connect it to ground. So this isn't even like a pain to route. Like even though it's quite small, the layout of the pads make it easy to assemble. So I'm actually kind of liking this. It's also inexpensive. It's only like 3 cents in quantity, 4 cents in quantity. That's good for a regulator. And so it's a little bit less expensive than the inductor, and it's much smaller. So if there are situations where I really want to reduce that board space, I don't want the EMI from the DCDC, I'm going to pick up the TLV74311 in the X2 SON, X2 SON 4-pin layout available at DigiKey.
And that is Great Church.
Where in the world